Hi guys! In this video, I'm going to show you how to conduct independent samples t-test in JASP.
Let us use this example to illustrate how to conduct the independent samples t-test in JASP. In this example, I want to see which sections of students has higher scores in the recently conducted midterm examination. I have two sections which are Aristotle and Archimedes. My dependent variables is the exam scores of the students, which is a continuous variable. And these are randomly selected. Given this information, my candidate test to be used is independent samples t-test. Now let us test at 0.05 level of significance if the scores between Archimedes and Aristotle are significantly different. First, we need to save this Excel file in CSV format, since JASP only reads CSV files. So go to save, then save as, then save it to wherever folders you want it to be saved. Then be sure that the type of the file is CSV or comma delimited. Then just click save. Now let us open our JASP application. And to import the data that we have, just go to the sidebar menus, click open, go to computer, then locate your file. Okay, so I can now see my data in JASP. Just make it sure that the level of measurements of your variables are properly set. So just click this left side part of the variable name. So in my case, score is my dependent variable. So this should be scale. And section is my grouping variable or my independent variable. And this should be at the nominal level of measurement. And since my data is now ready, just go to t-test and click independent samples t-test. And this analysis view will appear. So I will choose score as the variable and section as my grouping variable. Okay, so before we test using the student t-test or the independent samples t-test, I want to check first the descriptives and the assumption of the independent samples t-test, the normality and the equality of variances. So let's first look at the descriptives of the student scores. So in this part, we can see that Archimedes has a mean of 89.235, while Aristotle has a mean of scores of 84.633. From these descriptives, we can see that the scores of the students in the Archimedes section are higher than those of the students from the Aristotle. However, we have to check if this difference is significant. But before that, let me check the assumption of the independent samples t-test. For the normality of the dependent variables in each group, we have here, for Archimedes, the p-value of the Shapiro-Wilk test of the variable score is 0.673, while the p-value of the Shapiro-Wilk test for the scores of section Aristotle, we have 0.411. Okay, so from the discussion on the assumptions of the independent samples t-test, we recall that a variable is normally distributed if the p-value of the test of normality or the Shapiro-Wilk test is greater than 0.005. And since the p-values of the two sections are greater than 0.05, we can say that the scores in each of these sections are normally distributed. And for the test of equality using the Levin's test, we should recall also that the variances are homogeneous if the p-value of the Levin's test is greater than 0.05. And from this result, we can see that the p-value of the Levin's test for scores is 0.085, which is greater than 0.05 level of significance. So we can say that the variances of the scores of the two groups or the two sections are homogeneous. Okay, now, since we have satisfied these assumptions, we can now check student, or this is the independent samples t-test, and try to see the result. Okay, and here is the result of the independent samples t-test. And we can see that the p-value of the score, of the variable score, is less than 0.001, which is clearly less than 0.05 level of significance. So therefore, we have enough evidence to say that the scores between the two sections, Archimedes and Aristotle, are significantly different. Specifically, we can say that the scores of the students from the Archimedes are greater than those of the students from Aristotle.